Hey guys, I'm going to work through the test review here. All right, number one says a sphere with a radius of 6 is inscribed in a cube. Inscribed, that means it's the biggest possible sphere that could be in there. That means to the edge would be like from the midpoint up. So it means the entire side is 12. Find the volume of the cube. Well, if it's a cube, then it's going to be 12 by 12 by 12. 12 cubed is 1728. Number two, the length of the base of a prism is twice the width. So it's a rectangular prism, and the length of the base is twice the width. The perimeter of the base is 24. So we know that the length is twice the width and that the perimeter is 24. So that would mean 6W, right? If I add these up, has to be 24. So the width has to be 4, which means that the length has to be 8. Find the height of the prism if the volume is 160. So just again in our setup, the length was twice the width. So I called the width W, which means that the length would have to be 2W. And then add up all the sides for the perimeter. And the perimeter was equal to 24. Now we know that the volume equals the length times the width times the height. They tell us that the volume is 160. We know that the length and the width are 8 and 4. We just need height. So that's 160 divided by 32. The height would have to be 5. Next question says a trapezoidal prism. So trapezoid. So draw a trapezoidal prism, looks something like this. Oh yeah, that is a beautiful prism. Has a height of 15. They're talking about the prism here, so that means that the prism has a height of 15. The trapezoids have bases of 12 and 6. So if I focus on just the trapezoid base, we have 6, we have 12, and a height of 4. Oh, they just give us everything. Find the volume. So let's start with the trapezoid. The area of the trapezoid would be the average of the bases times the height. So what's the average of 6 and 12? It would be 9 times 4 would be 36. So the area of the base is 36, so then it would be 36 times 15, and I get 5,400. No, I don't. 540. Sorry, 540. There we go. Perfect. A right cylindrical glass, so cylinder. Diameter is 8, so the radius is 4. Contains water to a depth of 4. What volume of water must be added to raise the height to 10? Well, that would be a height of 6, so it'd be pi times the radius squared times the height we care about. And I would get 96 pi. Oh, round to the nearest whole number. And I get 302. So the final answer would be 302. A rocket is made of a cone on top of a cylinder. The cylinder has a diameter of 16, so talking about a cylinder. Oops. The radius again would be 8. The height would be 50. The cone has a slant height of 17, so there's a cone with a slant height of 17. So we need this right triangle. So we have the slant height is 17, we have the radius is 8, that's a triple, so the height would be 15. So for the cone, the radius is 8 and the height is 15. If 60% of the space in the rocket is needed for fuel, what is the volume to the nearest foot of the portion of the rocket that is available for non-fuel? So let's get the total volume. The total volume would be pi times the radius squared times the height for the cylinder, plus 1/3 pi times the radius squared times the height for the cone. So let's get what that is. That'd be 64 times 50 plus 64 times 15 divided by 3, and I get 3520 pi. That's the whole thing. But 60% is fuel. That means I need to multiply this by 40%, or 0.4. That's how much is left over. So times 0.4 times pi, and I get 1408 pi. But it says round to the nearest whole number. So I get 4423. 4423. Perfect. So 60% is used. That means we have 40% left over for non-fuel. That's why I did times 0.4. I added the cylinder plus the cone to get the total, times 0.4 to get what's left for non-fuel items. The volume of a cone is 800 pi. Find the height of the cone if the radius is 14. Well, we know volume is 1/3 pi r squared h. So we know that 800 pi has to equal 1/3 pi times r squared. Nope, we know r. So they said the radius is 14 times h. Well, the pi's would cancel out. So we would have 14 squared. So we would have 800 equals 196 over 3h. So I would do 800, we're going to do times 3 divided by 196. So 800 times 3 divided by 196, it says round to the nearest whole number. I get 600 over 49, which to the nearest whole number would be 12. Crushing it. Find the volume of a pyramid whose lateral edge is 20 and whose base is a square with an apothem of 12. Well, let's look at the square base first. The apothem is 12, means the whole thing is 24. It's a square base. So the area of the base would be 24 squared, which would be 576. So we know that the square base has an area of 576. Now here's where it gets tricky. We have a lateral edge. So let's go pull up a pyramid. Square pyramid to be exact. So square pyramid, oh yeah, here's a good one. I've used this one before. Copy that one. All right, so let's take a look at our pyramid. I know some of you guys already have this down, and I really appreciate it. But if you don't have it down, now's your chance. So we are given this blue line. That's a lateral edge. We need this, the height. What connects the lateral edge to the height? That is the radius. So we have a right triangle with a lateral edge, radius, and we are trying to find the height. That's what we're going to be working on here. So if I draw that right triangle, we need that radius. So let's think about the square. If this is 24 and 24, the entire thing, it's a 45, 45, 90. The whole thing is going to be 24 root 2, which means this part is going to be 12 root 2. So the radius is 12 root 2. The lateral edge is 20. So we need to hit Pythag on those numbers. So that's going to be the height is going to be the square root of 20 squared minus 12 root 2 parentheses squared. Make sure you put it in parentheses or it will be wrong. And I get 4 root 7. All right, so we have the area of the base, we have the height. So we're going to wrap it up. The volume is 1/3 times the area of the base times the height. Oh, it even has a root there. So it'd be 1/3 times the area of the base times the height. And I get 768 root 3. Nope. Root 7. 768 root 7. Got it. Find the volume of rotating the rectangle around an axis if the rectangle is 1 inch wide and 5 inches in height. the rectangle is 3 inches away from the axis. All right, I don't have room to draw the whole thing, so I'm going to kind of do it up here. But basically, if we have an axis, we have a rectangle, we would draw the reflection and spin it. And so it's going to be like a roll of toilet paper. So it's going to be pi times big R squared times the height minus pi times little r squared times the height. So the big R would have to start here and go all the way out. So big R has to be 3 plus 1, 4. And then little r would be just this portion, 3. And h for both of them would be 5. So it's going to be pi times big R squared times the height minus pi times little r squared times the height. That's going to be pi, let me get that, 16 times 5 minus 9 times 5. I get 35 pi. So the answer is 35 pi. Love it. An aquarium is the shape of a rectangular prism. Love it. Rectangular prism. It has a base that is 35 by 9 and a height of 18. Right now the water reaches 15. So right now the water level has a height of 15. How many cylinder-shaped castles can you put in your aquarium before it overflows if the castles have a radius of 2 and a height of 4? All right. So we need to know how much space we have left over. So we have from 15 to 18. So over here, that would be length times width times height. And the only height we care about is 3. How much space do we actually have? And we have 945, and that's all in inches. So we have 945 inches cubed. That's how much space we have. A single cylinder would be pi times radius squared, times the height. So one cylinder is 16 pi. So how many can we put in? It'd be the space we have. Notice there's no pi on that. Be careful, because that's a rectangular prism. No pi on that. It's just 945 divided by one cylinder. And I get 18.8. That means I can fit 18 of them. Number 19 would be no, no, no. All linear dimensions of a pyramid are multiplied by 10. What is the effect on the volume? Ooh. So it doesn't matter what shape it is. How many dimensions does a pyramid have? Volume is 3 dimensions. So we're multiplying it by 10 3 times. So it'd be times 1,000. For the following frustum, the circumference of the bottom circle is 14 pi. So quick reminder, guys, circumference is pi times the diameter. So if they're saying that the circumference is 14 pi, we know that the diameter is 14 and the radius is 7. So we know that the radius of the bottom is 7. Got it. The area of the top circle is 441 pi. Well, we know that area equals pi r squared. So 441 has to 441 pi has to equal pi r squared. So the square root of 441 is 21. So we know that the radius of the top circle must be 21. So the radius of the top circle must be 21. If the height of the frustum is 10, find the volume of the frustum. All right. So every frustum problem, we draw the same shape. We start with a right triangle. And on this particular shape, the bottom is smaller. Okay. So we're going to draw our triangle upside down. You don't have to, but the small one is on bottom at 7. The larger one is 21, and they told us that the height is 10. And those are numbers for the frustum. Remember that this portion is not actually there. Like that'd be the rest of the cone. It's not there, guys. So we got to label the parts that we actually have. All right, so x over 7 would equal x plus 10 over 21. It's got to be left over top equals big left over big top. We can reduce 7 and 21 to 1/3. So that'd be x plus 10 equals 3x. So we know that x equals 5. Now, if you didn't reduce, you would have to cross multiply. You'd have 21x, and you would have had 7x plus 70. You get the same answer. You just got to be really careful. Make sure you distribute. Either way, we know that x equals 5. So we know that this spot over here is 5. All right, so we have everything we need. We know that big R is 21. We know that big H is 15. We know that little r is 7. And we know that little h is 5. And we're going to subtract the two cones. So our final situation is 1/3 pi times r squared h for the big cone minus 1/3 pi times r squared h for the small cone. So 21 squared times 15 divided by 3, I get 2205 pi. 7 squared times 5 divided by 3 minus 245 over 3 pi. So 2205 minus 245 over 3. So I get 6370 over 3 pi. And they are saying that they want us to type in the coefficient as a fraction. I don't actually, oh, right here. So that would be 6370 over 3 pi. Woo! All right, Nick and Sam are playing with Play-Doh. When Nick first gets his Play-Doh from the container, it's a cylinder with a height of 3.5 and a radius of 3. So we know that Nick, it's a cylinder with a radius of 3, so it's going to be pi times 3 squared times 3.5. So that is 31.5 pi. One cylinder is 31.5 pi. Sam has the same cylinder-shaped Play-Doh, but he has 2 containers. Okay, so Sam would have that number times 2. Sam has 63 pi. Okay. 2 containers instead of 1. If Nick and Sam use all of their combined Play-Doh to make a cone with a radius of 5, what would be the height of their cone? So combined, we have 63 plus 31.5. We have 94.5 pi. That's their combined volume. And they're saying they're making a cone with a radius of 5. So volume of a cone is 1/3 pi r squared h. So 94.5 pi equals 1/3 pi. What do we say the radius was? 5 times 5 squared times h. So that would be 94.5. The pi's cancel out. Equals, this would be 25 over 3 pi. So we do times 3 divided by 25. Not pi. Who said pi? Alp. Was that you? It's h. So times 3, we have 94.5 times 3 divided by 25. The height would be 11.34. Now it says it just says type it in. It could be a fraction or a decimal. Okay, so that'd just be 11.34. Okay. If Sam, here's Sam, uses just his Play-Doh to make prisms that have a base area of 8 and a height of 6, how many can he make? So just Sam. So prisms are volume equals area of the base times the height. So he's saying that his prisms would have a base area of 8. We don't even care what shape it is. We know the base area. It's 8. And a height of 6. So that is 48. That means the volume is 48. We want to know how many of these he can make with his Play-Doh. His Play-Doh is 63 pi. So he has 63 pi. Each one is 48. So 63 pi divided by 48. I get 4.123. So how many can he make? How many complete ones? He can only make 4 complete prisms. Love it. Last question here. It says the following figure is 2 congruent pyramids with a prism in between, the bases of which are regular nonagons. The height of each pyramid is 12. Nice. They give us the height straight up. So for the pyramid, we have an h of 12. The height of the prism is 6. So that means this part's 6. Kind of hard to draw the height of the pyramid, but it's 6. The apothem of the nonagon is 11. We're going to have to get the area of that nonagon. So the apothem is 11. So for every nonagon, we draw this. The apothem's 11, 360. It's a nonagon, so we know that n equals 9. So there'd be 18 of these triangles. So there's going to be 20 degrees each. So this is going to be 11 times the tangent of 20. So the area of this shape would be 1/2 times the apothem times the perimeter. 11 times 18 is 198 tan 20 times 198 tan 20. So that would be 1089 tan 20. So that's the area of the base, and all 3 shapes have the same base. 2 pyramids, 1 prism, all with that base. So it says, find the volume of the entire shape. Leave your answer exact. The first blank is the coefficient for tangent. The second blank is the degree of the angle. Okay. So the pyramid would be 1/3 times the area of the base, which we said was 1089 tan 20, times the height. And they gave us the height straight up as 12. Looks kind of funny there. Plus the prism. The prism would be the area of the base, 1089 tan 20, times its height, which is 6. Oh, there would be 2 of these. So it would be 2 times 1/3 times 1089 times 12 plus 1089 times 6. I get 15,246. Don't forget there's a tan 20 on those things. So 15,246 tan 20. Not much to work there. All right, that's it. Nice, perfect.